we'll see questions about objects in the coordinate plane or the coordinate system. As you know, this is an imaginary plane in which we can pinpoint the position of objects, understanding geometric objects as made of the most basic objects available, which are points. So a point on a plane is determined by a pair of two real numbers. So this position regarding this horizontal axis is called x, and this value here is y. The signs of these areas of the plane are predetermined. To the right of 0 is positive, to the left is negative, above 0 is positive, and below 0 is negative. That's why the signs for the 4 divisions or quadrants are determined like this. So the first of math objects we'll see is the straight line. The straight line is a collection of points, an infinite collection of points that have a common characteristic. The coordinates x and y of any point that belongs to a straight line L on the plane share something in common. What is that? That no matter which point we're talking about that belongs to the line, the values x and y comply or satisfy a linear equation with two variables of the form a times x plus b times y equals c. So this is the way how we define a straight line on a plane. If the normal equation, including variables x and y or any two other variables, is modified in such a way that we can isolate the variable representing the vertical position of points, that is y, then we get this form in which these constant values have a geometric meaning. M is called the slope and determines somehow the direction and inclination of the straight line regarding the vertical or the horizontal axis. And B is called the y-intercept, representing the position over the vertical axis where the line crosses. So y-intercepts and x-intercepts exist. All you need in order to determine these two values, M and B, is to have the coordinates of 2 points or the coordinate of 1 point and the value of M, the slope. Okay? We say that a point belongs to a straight line if the two coordinates of the point satisfy the equation that represents the line on the plane. Well, for example, if we talk about this linear equation with two variables, as we said, this can represent a line on the plane. If we interpret that y is the vertical position of points, while x represents the horizontal position of points belonging to this line. So, using the concept of the intercepts, we can calculate the exact position where this line crosses the axis y and the axis x. Making y equal to 0, you can calculate the value of x, 10, and making x 0, you can calculate that y equals negative 6. So these are the 2 points on the axis where the line crosses. And you can see now the orientation of the line on the plane. If from this equation we isolate the variable y, we get this form where the constant or coefficient of variable x is called the slope, and this is called the y-intercept, that is this position exactly, right? And the slope gives an idea of the orientation and relative inclination of the line regarding the axis. Perhaps more importantly, regarding the horizontal axis. Let's see how the slope indicates that information. The slope of a line is a value, a real number, that is pretty much related to the value of the angle of elevation or inclination that a straight line has regarding the horizontal axis. So if we know a straight line and we can calculate this angle, then we can calculate the slope using trigonometric functions. But in the GMAT, we cannot use trigonometric functions because there's no calculator available. So the questions regarding the slope are actually very limited in depth because we can only interpret some values for the slope of a straight line in a general way. For example, a slope of 0 means just a horizontal line. A slope that is positive means an angle of elevation regarding the horizontal axis. Like this, for example, where a slope of 1, positive 1, means just 45 degrees of elevation. Of course, if you have a value of a slope that is greater than 1, that means simply that the angle of elevation, this alpha here, is simply greater than 45 degrees. The greater the slope, the greater the angle, all the way up to 90 degrees. The slope for an angle of 90 degrees, which means just a vertical line like this, is not defined, it's considered to be infinite. So the closer the angle gets to 90 degrees, you will have a very big value for the slope. What about the values of a slope that are positive decimals, that is between 0 and 1? That means values of this angle or measures for the angle of elevation that are between 0 and 45 degrees. And for negative slopes, is the same idea, but on the inverse. For example, a negative slope means that you have a line that regarding the horizontal axis has an angle of inclination or declination. That is to say, if the angle is exactly 45 degrees of inclination or descent, you can say that the slope is exactly -1. Values of a slope that are between 0 and -1, that is negative decimals, means angles between 45 degrees and 0 degrees of inclination or descent regarding the horizontal axis, while negative slopes that are more negative than -1 means that the angle of declination is an angle greater than 45 degrees. So that's how the sign of this value here, being positive, means that this straight line has an ascending slope. That is to say, if you move over the line from left to right, you go up. And the value less than 1, it's a decimal, means that this angle here is actually less than 45 degrees. So it's a soft slope. Based on this, we have also two special cases, horizontal and vertical lines. We said that if a line is vertical, the slope doesn't exist. So we have a special form of the equation of the line. X equals a constant value, and when the line is completely horizontal, the slope is 0. So the equation is like this, y equals a constant value.